Okay, so let's sort of have more of this practice about thinking about whether things are positive or negative in different quadrants and sort of how this all fits in with the reference angle by taking a look at the following type of a question. Let's find the sine of theta and the tangent of theta, but I'm not going to tell you theta. Sorry. What I will tell you is the following. First of all, the cosine of theta equals 2/3. So I'll tell you that. And I'll tell you something else. I'll tell you something about the cotangent. I won't tell you its value, but I'll tell you that it's in fact positive. So all you know is that the cosine of the angle is 2/3 and the cotangent of the angle is positive. That's all you know, and I want you now to find sine and tangent. Well, where do you begin? Well, basically what's happening here is this is some angle that's going to be somewhere. I just don't know where it's going to be yet, so I've got to figure that out. So let's think about it for a second. What do I know? I see that the cosine is positive. It's 2/3. That's positive. So where is the cosine positive? Well, let's think about it. The cosine's positive, of course, in this part of the world. Everything is positive here. And where else? All students take calculus. So in fact, here the cosine's positive. So the cosine's positive in this region, the first quadrant, and also the fourth quadrant. Okay. But we also know that the cotangent is positive. Now, where is the cotangent positive? Well, that's actually the same thing as where the tangent is positive. And the tangent's positive, of course, in the first quadrant. And then where else? All students take calculus. So in the third quadrant. So I know that the cotangent is positive here or here. I know that the cosine is positive here and here. Where are they both satisfied? Where are they both positive? Well, this quadrant right here, the first quadrant. So in fact, this must be going on in the first quadrant. Okay? Now knowing that, we can now draw a rough sketch of what's going on here. So rough sketch. You see how I determined just looking at the sines of these two things? This must be theta. It must live in the first quadrant. It lives in the first quadrant. And what do I know? The cosine is 2/3. And what's cosine? Cosine is adjacent over hypotenuse. So this must be a 2, and this would force the hypotenuse to be 3. Well, I wish I knew what that was, but not a problem. I can find that. Let me call that y. How can I find y? Well, I know that this squared plus that squared equals that squared. So that means that y squared plus 2 squared, which is 4, has to equal 3 squared, which is 9. So y squared equals 5. I bring the minus 4 over. And y would equal plus or minus the square root of 5, but since y is up in this quadrant here, I know it must be positive. Now, that's an important point. I want to say that again. I know that this picture is drawn accurately, so y can't be negative. Otherwise, it would be down here in the fourth quadrant. And I know it can't be in the fourth quadrant because cotangent will not be positive there. So in fact, the y must be the positive root. That's how I knew which root to use. It wasn't because I was looking at length. I was looking at this exactly as it sits in here. It's positive. So in fact, this is the square root of 5. And now I can answer any question you want about theta. You want to know, for example, the sine? No problem. It's going to be opposite over hypotenuse, so sine of theta is the square root of 5 over 3. You want to know the tangent? No problem. Tangent is going to be what? It's going to be opposite over adjacent. So tangent theta will be the square root of 5 over 2. Not a problem at all. So again, I used these two pieces of information about the sine to figure out which quadrant I was in, and then I was able to draw a picture and sketch. Same kind of question. Let's find now the tangent and the secant of theta given just two pieces of information. The sine of theta, I'll tell you, is negative 2 over 5. But I'll tell you something else. I'll tell you what the cosine looks like. The cosine is positive. Well, the first thing I try to figure out is where am I in the plane? So let's think about it. I see sine is negative and cosine is positive. Well, let's see. Where is sine negative? Well, sine is not negative here because everyone's positive here. All students take calculus. Students. So, in fact, the sine is also positive here. But take calculus, tangent and cosine are positive, so that means that down here in the third and fourth quadrants, the sign is negative. So this angle theta must be either in the third or fourth quadrant. Now which one? Well, the cosine is positive. So if the cosine is positive, where does that happen? Well, in the first and all students take calculus and fourth. So one of these two, that's where the cosine is positive. The sine is negative over here. So where do these things actually have something in common? Well, in the fourth quadrant. So this must be in the fourth quadrant. And if I know that, I know everything. So I see I'm living in the fourth quadrant, which I just did by looking at the signs of these things. So it's going to be something that looks like this. That must be theta. Now, what do I know about the sign? I know the sign is minus 2 over 5. So if the sign is minus 2 over 5, what does that mean? It means opposite over hypotenuse. Now remember, the hypotenuse, that value there, that r, is always positive. It's the length of that. So that's going to be a 5. And this should be a negative 2. And that makes sense because look at the picture. It's negative 2. Do you see how it's negative 2? What should this value be? It should be something positive because it's in the positive direction. How do I find that out? A little bit of Pythagorean magic. I'll call that x. And so I see that x squared plus this thing squared, which would be 4, has to equal this thing squared, which is 25. And so I see x squared would equal, I bring this over and I see a 21. So x would equal plus or minus 21. Now, should it be plus or minus? Well, the picture tells me it should be plus. If it were minus, then that would be way over here somewhere. Negative. So it has to be positive square root of 21. Well, now I know everything. What do you want to know? You want to know the tangent? Tangent of this angle is no problem. So tangent of this angle equals, well, it's going to be the tangent of this little reference angle, but I got to put the, be careful with the signs here. So what's the tangent of this thing? Well, it's going to be what? It's going to be opposite over adjacent. So negative 2 over the square root of 21. See how the negative sign is in there? Because all seniors take calculus, this should be negative. And there is the negative sign, because that's negative 2. You want secant? Well, I won't give you secant immediately. What do you think I'll give you first? 1 over cosine. So what's cosine? Well, cosine is adjacent over hypotenuse. So it's a square root of 21 over 5. And it should be positive. Let's see. All students take calculus. Yep. So it's positive. That's a good sign. And so if you want the secant, I've got to now flip that. Whoop. So instead of square root of 21 over 5, I see 5 over the square root of 21. So you can see that just knowing the signs, plus or minus signs, of two values of trig functions, that allows me to figure out which quadrant I'm in, and then I can actually just use the good old-fashioned trig together with a little bit of Pythagorean theorem to actually find out any trig function you want. Again, I want to give you a sense of sort of how things place in to the coordinate systems, and which things are positive, which things are negative, in which quadrants. Okay, well, that's all I really have to say about finding these cosines and sines and tangents and cosecants and cosines of all these different angles. What I want to start to do next is start to look at them all sort of en masse, all those angles together, and start to actually graph these functions as a function of theta. What does the sine function do as theta changes? We'll graph those things up next. I'll see you there.